Hello and welcome to this video. So we're going to look at solving chemical problems. In particular, this video is going to look just at your dimensional analysis part of it, which then we go into stoichiometry on. So remember that what you're going to be doing here is using conversion factors. Do remember that your conversion factors do not count in your significant figures, only the information that you are given in the problem, the measured value. Also remember, you always start with what's information that's given. You're going to multiply by your conversion factor, and that's going to give you your information you're looking for. The other thing is to remember that the unit that is in your numerator must be the same as your unit in your denominator so that those cancel. Because again, when you look at, if I was multiplying across, let's say, and doing our multiplication, I would have centimeter times an inch over a centimeter. And hopefully you remember that anything divided by itself is the number 1. Okay? And that 1 times anything is itself. And so that's going to give me inches as an answer here. So if whatever I have in the numerator and the denominator, they cancel each other out, is what we say, because they form the number 1. Yes, sir. Okay, sorry about that interruption there. So we're going to go on again. Same thing as I said. Given unit, your given unit goes in the denominator. Your desired unit's going to go in the top. Okay, so let's just run through a few of these and see what you remember. So we're going to start with the I do's down here. And so again, we write down what we're given. This would be this piece of it. So I'm given 154 centimeters. I'm going to multiply by my conversion factor. And since centimeters is what I'm given, remember centimeters goes in the denominator, I'm going to, or looking for, inches. That goes in the numerator. Now, if this is a multiple step problem, you may not be able to put what you're going to right there. But see, we've already got these canceling out. Now I just need to put my conversion in where it goes. And they do give you a conversion for that. If not, I probably need to make sure you have a conversion factor sheet somewhere. But the rule is that there are 2.54 centimeters in 1 inch. After that, then it just becomes a multiplication. Remember, the rule is we multiply numerator times numerator. So 154 times 1. And the label that's left there is inches. I multiply, and if you need to put a 1 here, you can. It shouldn't be something you need, but that's okay. 1 times 2.54 is 2.54. And from there, we need to go ahead and do our division. 154 divided by 2.54. Okay, now when I look at that, it does come out to be a very long number. I got a wrong number there. There's a 2. 1, 2, 6. Sorry. I would say, write it down, but at the same time, if you already know the number of significant digits and you don't want to write all of that number out, it's kind of hard to see. There you go. Then maybe you don't need to. So I'm given 3 digits. All I've got is a multiplication taking place. My answer is going to have 3 digits. There they are. I'm going to again look at the 2. So this is 60.6 inches as a final answer. Okay. Now, let's talk about work. I do expect you to set it up, show your work, show your cancellation. I will count off if you don't show your cancellation. This piece I would like to see 100%, but, understand if some of you skip that, you're in AP, some of you are regular, whatever, but you should be able to skip that. But I'm also going to tell you, I don't think it hurts to put it in. Same way with working this all the way out. Okay, so let's go on to number 2. So again, I'm given 3.14 kilograms. Now, some of you might say, well, can I just move my decimal because I know how to move my decimal? True, but we're trying to use unit conversion. So let's go ahead and just set it up as a unit conversion. So I'm going to grams. I'm given kilograms. And hopefully you know that kilo means 1,000 grams. So that's saying you have 1,000 grams. So 1,000 to 1. Again, I'm going to cancel my units. Okay. So if I multiply across, and that you can just multiply across, do that in your head, whatever the case may be. Here's my number. Again, grams is the only label left. I have 3 digits here. I only have 3 there. So I'm good in that way. Now, one of the things that I'm going to ask you to do is anything that is 1,000 and over. Okay. So anything greater than 1,000. Okay, so 1,000, I should, greater than or equal to, I guess I should say, 1,000 or over. I want you to go to scientific notation. So really you would need to write this as 3.14 times 10 to the third grams. And then I also think that that's a lot better to show you your 3 significant digits. Okay, so we're going to go ahead and do the next one. We haven't talked about it, but this is a conversion of volume, which some of you might find to be a little bit more difficult, but remember this is cubed and cubed. So let's just go ahead and set it up and see if you're okay with what I show you. 27.8 millimeters cubed. Now, I'm going from millimeters cubed to centimeters cubed. And the problem with that is that kids tend to only want to do the conversion one time. So what I really think is the easiest is to take your cubes off, and what you're really going to do is 3 of these, okay? So the reason why, let's talk about why. Because you have 3. So 1, 2, 3. And now then this will give you centimeters cubed. This is not the only way to do it. I'm just showing you one way. Okay, I lost my label there. Okay. Now, when I go to do my conversion, I know that a centimeter is 10 millimeters. So 1 centimeter is 10, 1 is 10, 1 is 10. Okay. Now I'm going to take my 27.8 and divide it by 10, 10, 10, or if you want 27.8 divided by 1,000. 1, 2, 3. And 10, 1,000. 10 times 10 is 100 times another one. And the way to remember that is you've got 1, 2, 3 zeros. 1, 2, 3. Okay, so that's doing a little bit of math ahead of time in your head. Again, 27.8 divided by 1,000. Hopefully you know that when you divide by 1,000, you move your decimal 3 to the left. So this is going to be 0.0278. And again, label of centimeters cubed. Now, that is one way of doing it. Some of you, I can show you a different way and it might make more sense to you on that. Okay. Now, one thing else you'll notice that I know Mrs. Standard and they'll do railroad tracks. I do it as a multiplication. I think that comes from me being a math teacher first. I just set it up like a multiplication of fractions. If you so need railroad tracks or whatever they call those, then you're welcome to put those in. I'm not going to say to not do that. Okay. I'm running out of room here, so I'm going to jump down to 5 and do that one real quick, just because I leave space, and we can come back in and do this one. So this one, 56.2. Now this has got, and I specifically wrote it this way for you because when you're doing unit conversions, you should not ever use the miles per hour this way. I think that causes problems when you're doing your unit conversion because people don't realize what's in the numerator and what's in the denominator. So always make it a flat line, horizontal line, instead of the angle. So again, I'm going from miles per hour to meters per hour. I'm not changing the hour bit of it, so you could actually even just leave that piece off of it and only do the numerator part of it, if that makes sense. We'll go ahead and do a conversion here because all I'm going to do is miles to meters, okay? And I honestly have to think about that one. So which way does it go? It's 1.6. So it'd be 1.6 meters. That's kilometers, 1.6 kilometers. So I'm going to have to change that value. So we'll do kilometers. So there's 1.6 kilometers to 1 mile. We'll use that conversion first. And like I said, if you don't have, I'll try to remember to get you, if it's not in your book already, conversion tables. And then this is where we have to do two. We know 1 kilometer is then 1,000 meters. So there's times you might have to do more than one conversion to get you where you need it. And if you had a conversion factor table that had from meters to miles, then that would not be a problem. Okay? The rest is just math. Again, because when I go through my labels, I have this left and this one I didn't touch. So we have 56.2 times 1.6 times 1,000. And it's 89920. And again, that's meters per hour. But I only have 3 significant digits. So 89920, whoops, 00. But I told you anything that is 1,000 or over should go to scientific notation. So 8.99 times 10 to the 4th meters per hour. Sorry, run over that. Meters per hour. Okay, so I kind of run a lot of space. Hopefully you don't write as fast as I do. But here's your, and I only did this one because I didn't have anything handy and I knew this conversion factor off the top of my head. Like I said, I'll get you guys a chart on that. So these two I knew already, which then I didn't have to do it. But multiplying across, then we're looking at significant figures. I've got 3 here. That means that has to be rounded to 3. And then I told you anything over 1,000 goes to scientific notation. So this technically would be your final answer for the problem. Okay, so the video is getting a little long. I'm going to shut her down, but hopefully that gives you some examples and then we can talk more about others.